right, Unit 4, tree graphs and identities. In first section 4.1, we will take a look at the graphs of sine functions and cosine functions. Okay. Okay, do you remember this? This is the lovely circle. You know, in the winter, my dog gets cold and then he just lies down and then he just has this posture and he gets every single part of his body and all together and then he makes perfect circle. I call him butter circle. And then this is another circle that I love. It's a unit circle. Okay, then the graphs of sine and cosine is nothing but unit circle itself. We just transfer this circle into linear shape. Literally, we transfer this circle into linear space. Okay, I will show you what I mean by transferring perfect circle into linear situation here. Okay, now let's take a look at unit circle really quickly. And as we remember from the first semester, from the standard position starting here, it takes the angle 0 and then pi over 6, pi over 4, pi over 3, and then here pi over 2, and then it goes counterclockwise and then it hits pi, and then we have all these angle measures, and then we hit 3 pi over 2, and then it goes back to the starting point, and then it was the same position, but now we counted up to 2 pi. And also, it doesn't stop there. After we finish the full circular motion, we will go over and over and over. And then also, that's not the only direction that we go over the circle. We can go negative direction as well, if you remember. The negative direction from the starting point, and then it goes clockwise over and over again. And around the circle, we also constructed each position with the coordinates. We were using all these coordinates to indicate all the exact values with the given angles and either sine or cosine. And I don't know if you guys remember. I hope you guys remember, but first the coordinates were exact value of what function? Cosine of the function, right? Then the second coordinates indicating exact value of sine function with the angle given, right? So all sine, 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 sine all around. And then all cosine, 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 cosine all around, right? So the way that we construct the graphs of sine and cosine are very similar to all other function graphing as well. We just figure out the position, which is the coordinates, the ordered pair on the axis. There's a horizontal axis and there is vertical axis, and we will find the coordinates on the axis from the unit circle. We plot the position and we connect those dots, and then it's gonna show you a certain shape of the sine and cosine parent function graphs. That's all. It's exactly same with all other functions, what we've been doing to figure out the shape of graphs. Okay, so now let's move on to next one. So if you're ready with any notebook or piece of paper, and if you have your own unit circle chart, then it might be ideal. But even if it's not, I prepare the image of the little unit circle right there. And it might be a little bit faster because you've never done it before, but I will simply show you the steps, the procedures of constructing sine graph with the unit circle here. But don't worry, as usual, I'm recording this video, so I will edit this video and then I will upload and separate on the module for you guys to go back once you have your own time. So it might be a little bit faster because you've never done it, but you will have the recorded video uploaded later. So we will just follow through what we are supposed to do to graph sine based on the unit circle first. Okay, here, as I explained right before, we will have horizontal axis and vertical axis on this plane here. Let me start with, let's say, now I just drew the horizontal axis here. And then I purposefully draw my vertical axis. It's just a little bit shifted to the left side. It doesn't matter. So then we can just have the center of the plane right here, right? Okay, then horizontal axis will be labeled with angle. Angle measures goes with the horizontal axis. Then what are the angle measures on the unit circle? Right here, 0, and in radians, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi 3, and so on. And then pi, this, and 3 pi over 2, and then this, and then it goes until 2 pi, and then it makes full circular motion there, right? So then these labels that indicates the angle measures are placed in this horizontal axis. Okay, then what indicates on the vertical axis right here, vertical axis, is the exact value of the function. First, we will start with sine. Sine. So sine function's exact values are second coordinates all over this unit circle. So all of this second coordinates over unit circle will be the vertical axis coordinates, right? Okay, then let's start with first one. Now, on the horizontal axis, the starting point is 0. The starting angle was 0 right here, right? Then we are going with the sine. So what is the exact value with the angle 0, the sine value? This is 0. So then we have angle 0 and the sine value 0. So the coordinate that I'm supposed to plot first is 0, 0. The first 0 is angle 0, radian angle measure 0. And then the second coordinate 0 is the sine value with the angle measure 0 is 0 right here. Okay, then now we will move to the right through the horizontal axis, and then the next plot, we still have pi over 6, pi over 4, pi over 3, but let's skip, and then let's plot pi over 2 on the horizontal axis. So now, let's see, this is pi over 2 labeled on the horizontal axis. Then now, I need to know what exact value of sine with the angle pi over 2. It says 1. So then that's gonna make the vertical position of the coordinate. And then let's say it's a positive one. And then approximate, it's just about this height is 1 on your vertical axis there. So now this plot is pi over 2 comma 1 there. Okay, then let's move on next label. Then if I go exact same distance from 0 to pi over 2, from pi over 2, and then let's say it's about this position, then let's say that's gonna be the next position, which is labeled on the horizontal axis as pi. Then what is the sine exact value with the angle pi? Right here, 0. So then the coordinate at that position is pi. When the angle is pi, the sine value is 0. So now the coordinate will be plotted on there, right? Then if I go exactly same distance from pi, then here somewhere I can label this plot on the horizontal axis as 3 pi over 2. So notice that I go by 90 degrees. From 0, I go pi over 2, first 90 degree. And then from pi over 2, I went 90 more degree, and then it's pi, which is 180. And then I went further 90 more, it makes 3 pi over 2, and then it's going to be 270 there. Then when I have the angle measure labeled on the horizontal axis pi over 3 pi over 2, which is 270, what is the sine value? -1. Then the coordinate is going to be, it's down here this much. Then now the coordinate is 3 pi over 2, comma, -1. Then I can plot there, right? Then let's go 90 degrees more. Then I will be able to plot this position with what's next? 2 pi as the angle measure on your horizontal axis. And then what is the coordinate? It's a 0. Sine value is a 0. So now I get to plot right there. Then when you do it by yourself on your time, go approximate all these coordinates in between 0, pi over 2 pi, 3 pi over 2, 2 pi. Then you can approximate the height of that coordinate, and then you will be able to connect those plots smoothly from 0, 0, pi over 2, 1, pi, 0, and 3 pi over 2, -1, and then 2 pi, 0, like this way. So now I see the circle was transferred to linear axis, horizontal and vertical. Then now we see very unique curves goes over from 0 to 2 pi. Then as we continue to move through circle like this positive direction or negative directions forever, my graphs are also continuing left side and right side, keeping the same shape. So it's technically, it goes over again, and then it technically keeps going again, left side and right side. Okay, any question? So we saw step-by-step of constructions of the sine curve directly from unicircle here, right? Then you should be able to find all this plots in between 0, pi over 2, pi, 3 pi over 2, and 2 pi again and again, right? And then it's gonna approximate along the curve, right? Then what do we do with the cosine? So then if I can just go a little bit faster and skipping, cosine graph will be transferring onto this plane, exact same matter. The only difference is as we go by the angle measures through the horizontal axis, we use these values, right? The first coordinate instead of the second coordinate. Then the first position, when we have 0 angle measure, this is not 0. Now it's 1. So it's going to start from here, right? And then we'll skip this 3 for now. And then when pi over 2, it becomes 0 now. So pi over 2, it becomes 0. And then when it's pi, it's -1. So now it's down here. Then when it gets 3 pi over 2, and then this is 0, so it's plot here. And when it goes back to 2 pi, and the coordinate, the exact value of cosine is 1, so it's gonna be up here. So then, exactly what we did for the sine, if I can connect those rough points, then now it looks like this from 0 to 2 pi. And cosine also continues the both ways forever. So it's supposed to go like this, supposed to go like this forever. So now, as you can observe from this quick plotting and connecting the dot and then getting the approximated shape, cosine and sine, actually they're the same waves, but they are shifted from each other in distance of pi over 2. If you shift one another pi over 2 to either right side or left side, they are going to coincide exactly the same. But for the parent function, for each functions, they're exactly same shape, but the position wise, they're shifted from each other pi over 2 much. That's really important discovery that we need to see and remember, okay? You should be able to see these edited videos later when I'm uploaded on the modules. But besides that, any questions so far? Okay, then we will move on. So as you see, this is the steps for you to follow. So if you see in detail of the sine function, the sine function graphs will look like this. And then compared to this, and cosine function will be this, right? Then here, if we quickly check the domain and range of sine, since it's continuous from both sides, domain is -infinity to +infinity. It exists everywhere in the real number line. And the range is, as we limit the unit circle has a radius 1, it's not gonna go over the 1, it's not gonna go lower than -1. So the highest point is 1, lowest point is -1 for sine. And when you see cosine, it's the same thing. The highest point it can get is +1. The highest point, lowest point it can get is -1. So range is -1 to 1, and domain is also -infinity to +infinity, right? But only difference is they're the same shape, same repetition, but if we see the same time, they're just shifted by pi over 2 from each other. That was it, okay? Then as you see, the sine starts from 0, 0, and then it goes up and down, and then it makes one repetition. And the cosine starts from 0, 1, and then it goes down, and then it hits the lowest point in the middle, and then it goes up, and then it ends the first repetition in the highest point, which is 1, right? So that we can compare them as some similarity and differences there. Okay, good. Okay, then besides this, there's 3 key features that we need to know about these curves, right? And I will explain the 3 key features. It applies to both in the next slide. But it's applicable for both though, okay? So this is a sine function. How do we know? Because it starts from 0 and then it goes up and then it hits the 0 in the middle and then it goes again. And then it's supposed to be continuous like this. Then with this, the first key features that we need to know is the amplitude. What's amplitude? With the graph, we measure the distance from the vertical middle to the highest point and lowest point. And then these 2 distance is exactly the same, but we measure the distance and then we call it amplitude. So that means we measure how far, either higher or lower, from the vertical center, and then we measure the distance, and then we call it amplitude. This is the first key features, okay? Then the second one will be period. Period is whether it's a sine or cosine, we measure horizontally from starting to ending of the one repetition shape. So this one period will repeat over and over again. So then one full repetition is called period. So this is the second key features that we need to know. It's called period. Okay. Then the third key feature that we need to know is a midline. So midline is the center itself over this graph, and then we see the midline position. So for a parent function of sine function graph happens to be in the middle on the horizontal axis, but it could shift up or shift down. So it's gonna have a different position later. But for the parent function, the midline is the vertical center of that graph. Okay, so that's the third one, key feature that we need to know. So the way that you construct sine and cosine, and then 3 key features for both functions, that the first one was amplitude, and second one was the period, and then the third one, midline. Knowing all of this, and you should be able to do all 10 problems of practice